Welcome once again to physics and mathematics lovers. So in today's physics class, we are going to solve some questions on projectile motion. So having understood the three cases of projection, so let us look at this past question. So the question says, a body is projected horizontally from the top of a cliff 45 meters above the ground. If the body lands at a distance 30 meters from the foot of the cliff, calculate the speed of projection. Take g as 10 meters per second square. So this type of question, we need to first of all get the diagram. Let us look at how to illustrate this diagrammatically. If today is your first time of coming across my page, please, I want you to do well by liking and also sharing this post. Now, solution. Let's go. We have that the body projected horizontally. That is to say, we will project it from the top of a cliff. And this is the height. The height of the cliff here is 45 meters above the ground. Now, the object will be projected from there, okay, with an initial velocity. Remember, this velocity with which it is projected is known as a horizontal component of the velocity, okay? And the object will land here at this point, and this is the point of projection. Then distance says 30 meters from the foot of the cliff. So this is the path where the object will move, and that is the trajectory of the projected object. Now, what we need to do is to calculate the initial velocity. First of all, for us to do that, we are going to, first of all, get the time of flight. Yes, so we need to get the time of flight from the equation 3 that we know, the time it will take for the object to land. And for us to get that initial velocity, we must get the time of flight so that we can substitute the value and get our initial velocity. Then let us look at the vertical motion. The vertical motion there, u of y is what? 0, because the object is coming from a height. The object just dropped. Now we use that equation 3 of linear motion, which becomes uyt, that is multiplying the initial velocity plus what? Half gt squared. And remember, acceleration now becomes g, which is acceleration due to gravity. Now at that point, since u of y is 0, that means the vertical component of the velocity becomes 0. So that means we have h equal to what? Half gt squared. So from here, we can calculate the time of flight. Then substitute 45 for h equal to 1/2 times 10 times t squared. Okay, now we can cross multiply. We have 45 times 2 equal to 10t squared, so which now give us 9t equal to 10t squared on the right hand side. Now let us cancel out 10 there. We have 9 equal to t squared. So from here we can get the value for t as the square root of 9. Therefore, t, which is equal to what? 10, that is 3 seconds. Square root of 9 is 3. Now from here, we can get our velocity from the equation which says the range is equal to ux multiplied by the time of flight. So at that base, the body moves with what? The horizontal velocity. So range is equal to ux times the time. And that time we got there is 3. So what we just need now, we know that the range here is this 30 meter, the distance from the landing point from the point of projection, that is the base of the cliff. So it becomes 30 times, okay, u times 3 equal to 30. So u becomes 30/3. So our velocity of projection is 10 meters per second. So this is the answer to this question. So our correct option here is A. I hope you find this class very interesting. Please help us to share this post and do well to like and comment. Also subscribe to my YouTube channel, physics and mathematics lovers. There I will be bringing different topics on mathematics and physics. As you do so, God bless you. Bye.